Hello, Jason here again. We are at International Race Cars, and let's review the rear end stuff, hubs, and brakes that we have been developing here at IRC, and we are currently selling. We already sold a few housings to a few builders, a few race teams, etc. Morgan Clark getting the last one to come off the fixture technically. The one on the fixture right now is actually going to a mid-engine TMR car, but let's review kind of our overall what we're doing here. So we ended up developing all of our own rear ends and everything in-house for our all-wheel drive program, and that has led us to now building and selling these parts to others, not just for our own in-house builds. So we have two perfect examples of kind of like what we're offering here. First and foremost is the big TIG welded stuff. So this housing right here is out of the mid-engine all-wheel drive truck, and this one right here in essence is a pre-runner, or a lower cost incursion race truck type application, MIG welded, all 4130. Both of them are 4-inch housings. I don't think we're going to do any 3.5-inch stuff. I don't know if there's really a market for that anymore, so I'm pretty much just focused on 4-inch stuff. And we do build these a little different than most. So for example, on our big TIG welded housings, all of these are going to be heat treated, and they are done in 3 pieces. So we have, in essence, your 2 sides and your center section. We weld those up independently, and I will edit in some pictures to showcase exactly what I'm saying so it'll make sense. Then it goes to heat treat. Then we machine the face of the center section. Then it goes into a fixture where we do the tube setting. And then once the tubes are set and welded to the center section, then we go back and we overlay the other plate work and get everything else connected. And so what happens here is we end up with about 15% of the welding post tube setting. And I mean that's everything. So prior to heat treat, we put lower link tabs on, bump stop pads on, the trussing, upper links, pretty much everything we can. Then it gets heat treated, then it goes into the fixture. So what's happening there is we are drastically improving the straightness, the robustness of the assembly by doing a lot of that work on the front side and letting all of that wiggling happen prior to any alignment. Then once it comes out of the big fixture, it's all straight and nice. We don't have to use a torch to straighten it. We don't have to use a press to straighten it, none of that stuff. We're able to basically pull it from there and set our snouts. Once the snouts are set, from that point we can then do caliper tabs, finish out the remaining truss of the caliper tab, and it's done. So in essence, what you end up with is a completely treated housing with very little post welding and very little wiggling post welding, so the movement of it is super mellow. That means we have a very straight assembly that's, for the most part, pretty much 85% of it is already stress relieved and cherry. The only other way to go past this would be to fully heat treat the assembly as a complete assembly, which I've done in the past, and it just is not worth it. It doesn't work how you think it would work in regards to keeping it straight. That's the catch-22. So as far as getting us the most robust assembly with the best process to come out with a proper rear end, I feel like we've done the best we can without it just becoming an insanely expensive endeavor to where it's just completely unobtainable in any sort of metric for racing. With that said, these are definitely going to be on the much higher end as cost incursion as opposed to the MIG welded ones. So for more of the ground and pound everyday guy, someone who's a little bit more cost incursion concerned, these are going to be obviously a lower cost incursion than this stuff. These are still all 4130, including the face plates. These are built in 3 pieces, the same process that we do for this, same tube setting and everything. We do pressure test them before they leave the facility. They actually get pressure tested before snouts go in. And this is a true 4130. Some of the manufacturers, they actually are using mild steel face plates, and they'll do 4130 for the tubes and trussing. Some of them are actually just mild steel center sections entirely. The main reason that they're doing that mostly is because the 3/8 material for the faceplate in mild steel is significantly less expensive than the 4130. We actually do all 4130, so yes, our cost incursion is more. We actually weld these up in our 3-piece fashion, just like these, and then we use exclusively very specific fillers. So on this guy, it's an ER80S D2. On this guy, all the stuff prior to heat treat is a filler material I do not want to disclose. And then the filler material that's used post heat treating is the ER80S D2. So there are very specific things in both of that sides of the table, whether it's MIG welding or TIG welding, that obviously complement the chrome moly material. So we're not using any 70 series, and we're not doing any mild steel in any of the housings, including the face plates. Then when it comes to all of our fillers, we use our own 2-inch diameter fillers. So these are an IRC part. They are incredibly thick, so that when they are welded on, we don't have any weird tapping that will occur or warpage into the assembly. They just go on nice and straight. It uses an O-ring to seal on the interior side, and it's a half drive socket for the top side. So instead of a nut or something else, we just went straight to a half drive, because pretty much anybody has that regardless of the sockets that they may or may not have. For all the vents, we run our own -8 fitting. So it's a -8 ORB for all of the venting on the rear ends. That's what this one is right here. We have not put the vent onto this housing yet, only because we haven't pressure tested this housing. Once it's pressure tested, then we can finish this housing out. Additionally, from the housings, we've also developed all of our own hub assemblies. And just like how we're building the housings, of course, the hub assemblies are done differently. Primary thing here is we have two sort of genres, and I haven't quite got there just yet on the pre-runner side or the smaller side, so we're just going to focus on the big trophy truck stuff now. So these are 80 millimeter bearing hubs. These are what we're using for our trophy truck applications. So what that means is, if you were to cross-reference this to the standard 3 1/4 bearing, even though the diameter of this is technically lower than 3 1/4, we actually have a much wider bearing. We actually have a much more robust bearing. These are less expensive than the standard 3 1/4 bearing. On top of that, they are readily available. So all of our international based clients, they can easily obtain this 80 millimeter bearing. It's literally right off of Amazon. So again, something that we're doing differently is we run all metric across the board for our assemblies. And that shouldn't be something that scares anyone here in the States, because again, these are just literally from Amazon. It's a really high quality bearing. These ones are actually made in Germany. The 60 millimeters that we use for the fronts are made in Japan, and I will explain that in a second. But this 80 millimeter bearing is very similar to what we're calling in essence our trophy truck or 3 1/4 stuff. It's still the same dual taper roller bearing assembly. It's a very large hub assembly. This is a 6 on 6 1/2, 11/16 wheel studs. It's all the main trophy truck stuff. It still runs a 36 big spline axle. So everything is the same as you would say appropriate for normal 3 1/4 inch trophy truck bearing hubs. The difference is our assemblies are metric based. So obviously the snouts and everything are 80 millimeter. These hub bodies are designed for these bearings, so we don't technically cross-reference with others. So in other words, you have to run our snout, you have to run our hub body, you have to run our bearing packs. Other than that, it is a very normal setup in that the dual taper roller bearing still is on the inboard side of the wheel mount surface, because you have your drive plate assembly there. We do run an indexing drive plate, to be fair. So our drive plate actually does index into it with obviously an O-ring, and again, fairly standard and normal stuff when it comes to the trophy truck applications. So there's nothing different in that. We do, however, run well, let's go into the front 60 millimeter bearing stuff. So for the front, the traditional would be more of like a 2 1/2 inch bearing. So a 549 from Timken. That bearing itself is fairly stout. Obviously everyone's running it. What we're doing is we run 60 millimeter bearings for all of our front stuff. And what I was getting at for the rear is I was contemplating making 60 millimeter pre-runner hubs as well that run 40 spline axles. So if we do get interest in that to do something for like these housings, I may actually end up doing that. But we'll see. That's something I had a few questions on, but I have a feeling pretty much everyone is running trophy truck type stuff that's going to be ordering something along this genre. So now let's focus on the front hubs. This hub right here is off of the all-wheel drive car. Actually, this is our portal hub. It runs 3 bearings on the snout assembly, and it's all metric. Our portal is entirely metric. So from the bearing assemblies to the gearing, etc. We are definitely different than say like the X-Track based stuff. Portal wise as regard to like what Mason had, and then in essence what ID sells. We are completely metric from all the bearings, including the snout bearings and including all of the portal bearings in the assembly. Same with our tooth patterns in the actual gear sets too, to be fair. It is, in essence, a hair smaller diameter, but again, the snout that we machine for it and everything is all appropriate relative to wall thickness. The cool thing here is all of our hubs, including, this is our 6100 hub right here, or a rear-wheel drive truck hub. This is a all-wheel drive truck hub. The bearing itself sits here, as you can see. It sits outboard of the wheel mount surface. So, to accomplish that, hi Hannah, to accomplish that, we run a 5-inch center bore on our wheels. So our center bore is much larger, Hannah, one sec, love. Our center bore on our hubs is larger than the standard 4 1/4 or old standard, I would say. We run a 5-inch center bore now, and that allows us to run a really proper 60mm bearing outside of the wheel mount surface, which creates an incredibly strong setup. And that's no different than our rear wheel drive hubs right here. So this is from our 6100 package, and or anything in essence, it'll be like rear wheel drive truck. So a front engine trophy truck, a mid engine trophy truck, for example, or our 6100 is running this hub, which runs the same 60mm bearing that our all wheel drive trophy truck and all wheel drive class 1 runs as well. So that's a quick rundown on, and all of this stuff, you know, in essence, is all going to be proprietary by default. So it's not like you can just swap hubs and swap snouts. You have, in essence, complete sets and complete kits. Hannah, 3-year-olds, man. Thank you, Hannah. So if we are thinking about doing snouts for our front hub stuff too, that in essence will cross over to the standard 12-bolt pattern stuff as well. And from there, in essence, you could, in theory, bolt this on. And so that's one thing I'm going to have coming down the road. Currently, our 6100 stuff runs an upright that we machine that has a press-in snout. So that is a little bit proprietary to us, but I am going to make the 12-bolt standard snouts as well to adapt our 60mm trophy truck front hubs and brake systems to the normal applications, which would actually be like the faceplate that we have off of DIY. That's a standard snout block that in essence would be like in everyone else's sort of application. So I got a little bit of grease. Let me grab a rag. Okay, so now that we've kind of gone through some of the hub stuff with our different bearings, hopefully a little bit of explanation as to why we're doing things differently. First off, one, we have international clients, so obviously I have to make sure sourcing is international. I developed 80mm bearing rear hubs almost 15 years ago for some international clients, so that's how I do where and what to grab on that. So if you're going to compare them to, in essence, the industry norms, we're not only more robust, but we're actually cheaper for the rear bearings, and the front bearings are basically the same cost as a 2.5, to be fair. Hannah, give her a minute. Hannah, do you want to come here? Do you want me to hold you? Okay, and we are back. Hannah is chilling now, so we're good. On top of all of the hub stuff, the rear ends, we also have new brake packages that we have developed. We're utilizing Stellatech 680 6-piston calipers. This is a race caliper comparable to multiple other manufacturers that would be the higher end, so to speak. These are made in Australia by an Australian engineering firm. The same firm that did all of the 5-axis machining for our portal bodies and some of those other bits. These guys are by no means new to brakes. They have a lot of experience. I don't want to disclose, I'm not sure if I'm allowed to disclose where they previously worked, etc. But long story short, these are a proper 6-piston, and we have our own rotors to match the 6-piston for these guys. So all of this is going to be available shortly. We are the distributor for the US for Stellatech in this race application. We have quite a few sets already here, and we have several sets on the way. We just sold another set of this to Morgan Clark for one of his builds as well. So race car stuff on down, this will be applicable to a high-end 6-piston that you see from multiple other manufacturers. When it comes to pairing them with rotors, well, these are designed around rotors that range 14 to about 15 inches in diameter. That's what the 680 works best for. So for our 6100 applications for the all-wheel drive class 1, we are running a 14-inch by 1.25 inch diameter rotor that this is actually our design in essence to complement the Stellatech, and that is the same one that's right here. It's already been ran several hundred hard miles. For the larger stuff, in essence, our all-wheel drive trophy truck was developed around an 18-inch rim, and the reason for that is we developed a 14.8-inch rotor that is actually 34 millimeters thick, and this is actually a floating rotor assembly. If you look closely, you can see the ovalization in that, but we run a floating rotor on our rotor adapter and rotor engagement, and this obviously forced us to go into an 18-inch wheel. So 2 years ago now, almost 3 years ago now, we had Innovate make us custom 18-inch forgings, and that is what gives us the clearance to run a 14.8-inch rotor. So all of our big all-wheel drive trucks, whether it's the portal, non-portal, mid-engine, they're going to run a 14.8-inch rotor. All of our 6100s, more pre-runner based stuff, our class 1 that's all-wheel drive, or to be fair, the two-wheel drive class 1s, they are running our 14-inch, 1.25-inch rotor. So this is just a quick overview of all the stuff that we have developed that we are selling outside of our own race program. We developed it for our own race program, and like I'm saying, we've already sold a few rear ends that have already left the building. They're already at other builders, like Morgan's, etc. And then as far as the brake stuff goes, we've already sold several of these packs too. So all of this is going to be kind of in conjunction. If you're buying a rear end, in essence, we can set you up with hubs and all the brake stuff. And as far as the front stuff goes, like I'm saying, I am going to work on doing a bolt-in deal for all of the rear-wheel drive standard hub stuff on a 60 millimeter bearing. So that's it for today, gentlemen. Pitter patter.